Okay, so in 4.2.1, which I kept calling it 4.2.1, 4.1.2, I did it again. We helped Renard with his equal values method. Where you set those equal to each other, if you remember that. So we have two equations down here. And the purpose of systems of equations, which I was completely embarrassed. Garrett, if you're listening to this again, my boss comes in and asks them, what are you doing? Why are you learning this? What's the purpose of it? He had no clue. At least he did not answer him whatsoever. He was working on a problem, one of your homework problems, and he's like, well, how did you get that answer? He goes, well, I first did this times this and this. He goes, no, I don't want to know how you solved it. I want to know why you're doing systems of equations. Okay, systems of equations is an easier way to find where two linear lines cross. Okay, the point of intersection, because it's not going to be as accurate if you have two linear lines and you try to just to graph them. Okay, you guys should know that by now, because what throws it off is you might lean one of your lines this way, and it's just it's personal error of what happened. So whenever you have a chance to have two equations, use the two equations. You're going to be more accurate when you have them. Okay, you should have learned that last year when you were talking about slope-intercept form. When you found slope-intercept form, that is going to allow you to draw one line more accurately than having two. Okay, so we actually have two here. But what we need to do first, which last time, we substituted this, which was so much easier, which is actually what they do on the backside. Okay? Well, now we're going to do the equal values method, where we need to set them equal to each other. So we're going to need to solve here for y. We're going to have to solve this equation for y to be able to set them equal to each other. And that's what that says. It says y is equal to negative x minus y. All right? So what's our first step going to be? And don't say divide by 5. Yes, Guy?
Don't you have to divide by yourself?
Yeah, but what do we do first? Don't say divide by 5. We're going to do something with our x term.
Minus 3.
Very good. You see any of that on those videos you watched, Emily? Huh?
Yeah.
Yeah, you did. So I don't do those videos. I'm kind of having just to torture you. Okay? Some of you are very visual. That's another way of learning. Okay? You also hear it, auditory. And then if you take notes, you have that too as well. If you take any notes from any of there, you can use it on your test. Okay? So those cancel out. So now we have 5y, okay, equals, now I usually put my x term next because that's what we do in slope-intercept form. Okay, so everyone needs to be copying this down. We did the substitution method on the front, so much easier, much cleaner. The thing is, when we went to the back side, after we did all of this mess, okay, the kids in Thursday, Friday, didn't realize it was the same problem. They should have the same answer. I'm like, you guys, come on, wake up. So now we have to divide by 5. Every term. And it's not pretty at all. Because now we have to deal with fractions. Okay, and I would leave this like it is. I would not change it to a improper fraction. Because you're going to have to change it back anyway. Okay? So now we need to set them equal to each other. So, we need much more room. And a different color so you can see that. So I'm going to do negative x minus 7 equals 3/5 x minus 13 fifths. Has anyone ever been taught the fraction buster method? No?
I mean, maybe it was a different name.
That was one strategy that in our old pre-algebra book when I first came here that I'm like, oh my gosh, that is so awesome. I wish they would have taught that to me when I was in school because it gets rid of those fractions. Kids your age do not like fractions. Whenever you can turn things into decimal, you love to turn things into decimals. But we can't do that here. So, when I talk about a fraction, what would I do to the 3/5 to get rid of the denominator? What could I do to it? Think about cross multiplying. So I'm going to do the same thing to every term. So whatever I'm going to end up doing over there, I'm going to do to this side. And I don't have enough room. Gotta do this. Why substitution is so much easier. What am I going to multiply that fraction by to get rid of that denominator? Cross multiplication. Guys, you know what? What would cancel out this denominator? How would I write this as a fraction to cancel out this denominator?
Oh, you do it.
What's that?
5/1.
Yeah, very good. 5/1. 5/1. That's how you get rid of it. That's why it's called fraction buster. Okay, fraction buster. Okay, this Emily and Sky here. Answer Emily's question. I know, sorry. This is harder than the
Huh? I really don't know. I think.
If you keep doing well, and everyone will get one before we leave, okay? Okay, so, I know this is hard. This is X, this is not multiplication. This is multiplication, because look what happens. That cancels out. That denominator is gone.
Oh, we don't know.
You did that before? Yeah.
It's 3.
So it's gone, so you don't have to find a common denominator. So minus 13/5 times 5/1. So the 5s are gone again. But whatever we do to one side, we must do to the other. So we have to multiply all terms by 5. You don't have to put it over 1 because those are not fractions over there. Now, look at how short it was the first time we did it. We haven't even found out what X is yet.
Yeah, it's crazy.
The equal values method is so much longer. So right now we have negative 5x minus 35 equals
Equals. Equals.
3x minus,
Minus
13.
right, minus 13. Good. All right, so this number's larger. What I know about numbers, this number's larger, so I'm gonna take it over here so it makes it positive. So I get rid of that negative sign. And then that makes it 8x. Okay, so now I'm going to, and this is going to be equal to if you can do shorter cuts and you don't need to write down everything, just don't mess up. Okay, if you're getting to the point where, why does she make me write down every step? Well, if you have to write down every step because you're not following along, write down every step. And if you have to draw this silly vertical line here, then draw it. But if you have to go to e-learning, you can't draw that very well. It just messes everything up. That's why I draw this, because technically it's an addition problem or a subtraction problem, depending on what sign you have. That's what my teachers taught me. So when you become a teacher, a lot of times you teach like you were taught, except my college professor at Purdue would come in every day and say, your high school teachers didn't teach you anything. He was right. We have one problem to do like this, and we have to explain it all in words every night. Okay, now we're still ready to solve for x, and we know we should get x is equal to negative 11, right? We know that. We hope anyway. So now we're going to add 13 to each side. Unless I made some error. I may have. I did. Somewhere. Paper out. No, we're not quitting. I never quit. I never quit. I never give up.
You watch me.
You know, I'm thinking 13 over 5, man. 5 can't go. It's 13.
Oh, what's in here? Maybe not.
Don't you want to get X on the left first?
Doesn't matter. You can do either or.
22.
You can do it, but you don't have to.
Maybe that was 13.
It should be. So, no, but the 8x is wrong. I did something there. My sign's wrong. Because it should come out negative 11. So my sign's wrong somewhere. All it takes is one wrong sign.
There's that one.
That's right.
Oh, were we supposed to do plus 3x on the left side of the equal sign?
Huh?
Plus 3x on the left side of the equal sign?
Where?
I don't know, man. It's just good, girl. Then we got negative to the right.
Oh, yeah. I didn't carry my negative over. Right?
Sure. Sure.
Yes.
Yeah. I didn't carry my negative over. So then that would be, make this, then this would be a negative. And then this, there we go. Figured it out, didn't we?
I figured it out.
Good job, guys.
Thank you.
Good job. That's why it's, I know. That's why it's nice to check each other.
You're welcome.
And I'm having trouble with that board today.
You're on a race here.
I know, but it's been freezing today.
There you go.
There we go.
I think that's another 2.
Okay. All right, we'll get through it, I promise. All right, so this is 2x. And then we're gonna add 13. And what do we get? Negative what? Very good. And we divide by 2, and what's x? Negative 11, right. We did it, yay! Now we have to go back to the equation that had y by itself. So y equals negative x, what? Minus 7, right? And we plug in, here's what's Grayson and somebody else messed up on.
Oh, Grayson never mentioned it.
He was mad at me because I counted it when I told him he wasn't right. He looked at me like, I'm not wrong. I'm like, okay.
I'm gonna be wrong.
And Evan got it right. He was mad because Evan got it right and he didn't. So he's very competitive. And somebody else too. Oh, it's Katie. And I said, you both made the same mistake.
Dude,
They came up with +4. What did they do instead? Emily?
Something.
when they put the negative one, they didn't put the negative one.
They did not keep the negative sign with it. They did not use those big gorilla parentheses, I tell you guys, right? And I think I'm silly, but they are so important because this is a negative, that negative there makes it what? Positive. Very good. So then we have 11 minus 7, which is what? 4. So y is equal to 4. So you have to do this in the answer. Since we're looking for the point of intersection, you have to put it in parentheses. So the answer would be negative 11, 4. Because this is the y, this is the x coordinate, and that's the y coordinate. You cannot just leave your work out here to hang out. Because you have to be organized. Okay?
Yeah.
So now,
First one's much easier.
yeah,
Yeah.
way easier. So now look at the second page, which is basically what we did on the first page. All right? I did things backwards for a reason. So we use substitution. So wherever we saw the y in the second problem, we put in negative x minus 7, right? That's what we did.
Yeah.
So we said this. We said if y equals negative x minus 7, then does negative x minus 7 equal y? Do they equal? Are they
Yeah.
equal? Yeah, it's the same. It's common sense, right? Okay.
That's because my brain said
They want to argue with me about that. They're like, no, that's not their no. And I'm like, guys, all I did was flip it. It's just like saying that x is equal to 2 or 2 is equal to x. It's the same thing. Okay, it just has another number on it or another variable. So they can be switched. Easy. Okay. So we're just going to put yes. They are equal. And I'm going to use the equal sign to make it easy on you guys. Okay, so the same thing. It's the same. Since you know that y equals negative x minus 7, can you replace the y in the second equation with negative x minus y with it from the top equation? Yes,
yeah.
they are equal, right? Very simple. Because it says y is equal to this. Y is equal to this. Now, if they misspoke and they were different equations, then they could not write that. Okay, pretty simple. Am I going too fast?
No.
Okay. What did you say, Lucas? I'm going too fast, slow me down. Sometimes I talk really fast. Once you replace the y in the second equation with negative x minus 7, you have an equation with only one variable. That's how you can solve, like here you can solve for x. We could have switched that around in the last equation, and we could have had x out by itself and solve for y first. It doesn't matter how you do it. Whichever one you want to choose. I always pick to solve for x first because it's always the first one that you list, okay? So this is called a substitution because you are substituting or replacing y with an expression that equals that. Okay, so you guys already solved this. I'm not gonna make you do it again. This is where Thursday and Friday students, they're solving and they're coming up there like, I don't know how to solve this. I don't know how to do this. I'm like, guys, isn't this the same problem that we just did on the front side? Oh, yeah. Should we get the same answer that we got? Yeah. Right? So basically, -11 and 4. Now,
This is great. They just make mistakes for us and you can stop.
Yeah.
how would I prove that this is right?
Substitute in that parentheses, or no.
How can I prove that that these points are right, even though I'm giving it to you?
Substitute for X. Substitute for Y for X and break the difference for
Yeah.
negative
The 4 in for X?
The negative 11 instead of the parentheses for
Okay. All right, so 4 is Y, right?
Yeah.
Okay, so I don't have Y in I'm using this equation right now. And we'll worry about Y in a minute. So where do I put the -11? Right, where the X is, right? So that's what I need to write down. So we're gonna check. This is our check. This is how we check this to make sure it's right. So I put for X, again, you guys said, this is the issue. You need to put that -11 in parentheses, because that negative is in front of the X. -7, parentheses, plus 3, parentheses, which means times 11, equals 13, -13. Okay? So, when I solve this side should be -13 because that side is -13, right? If it is, then I did it correctly. Then we can substitute in wherever the Y is up there and right there and see if we get -11, which I never do. So anyway, here we go. So we have 5, and then we have negative, times a negative is a positive. So 11 minus 7 is 4. Put that in parentheses because you're multiplying that. Plus, what is 3? Actually, I should wait a minute. What is 3 times -11? Right, -33. Equals -13. So we have 20 minus 33 is what? Does it work out, right?
Yeah.
Yep, it checks correctly. Then we can put the value for Y back in there, okay, which is 4. So we have 4 equals -X minus 7. And we're going to solve that. So we add 7 to the other side. Which we get -X equals 11. And we have a negative variable. No, so what do we have to do? Huh?
Divide by negative.
Yep, divide by -1. Divide by -1. So X is equal to -11. So it checks out twice. Double checked it. Triple checked it. Quadruple checked it. Okay? Hmm?
Other side.
Which one? Found it.
Yep, thank you.
He's been commenting. So I'm gonna end up giving everyone something. I get Carson to talk. Okay. So we are ready for page 3. Okay, you're ready for page 3. So I'm gonna let you guys look at this. I didn't let them do this. 2 of these are going to be your homework, whichever one we don't do together. Whichever 2 we don't do together is going to be your homework, okay? we are going to talk about 34, which you should know how to do 34 because we just did it similar on that problem like 34 is. And we'll solve that one together. And then 35 is part of your homework. Okay, do not overthink 35. Do not overthink it. I don't know how many people, Grayson and Logan got in an argument about that problem before they left the classroom the other day. Okay? And Grayson was right on that one. Because they had to come and see me during the library and settle it before they could go home. So anyway, so I'm gonna have you pick, so look over those 4 problems, all right? And we're gonna go down to that last problem because we just did the other problem just like this, okay? You guys told me.
Yeah, we can do these.
Okay, you're not the only person in here, that's it. So, it says, what happened? How can we prove, without solving it, that, I don't know how you pronounce that name, meh, solve the systems of equations correctly. My dog says it to me all the time, meh, maybe it does. So without actually doing it. So she's saying that x is equal to 4 and y is equal to 2. What can we do to solve it to see if it's correct? To see if she's correct. That is right. And we don't have to do both because she's saying that that's the solution. So we could pick just one problem and see if it works. I'm gonna pick the easiest one, the bottom one. So I'm gonna put 4 minus 2 times 2 equals 0. So what's 2 times 2? 4. And 4 minus 4 is 0. She's right. Okay? All right. We're going to go look at 35 real quick. And then I'm going to do some of the 2 of the other ones together. Down, but and I'm going to underline some important information. Usually in a story problem like this, all the numbers are important. Part of it is deciphering what it means by twice as many, when you add, when you subtract, when you have totals of something. Okay? And then usually what the question is asking you. So I always go there first. How many green marbles are in the bag? So that's one of my variables. So I know G stands for green marbles. Now here is the confusing part. Trying to decide in your equation if you're going to have 1 variable or 2. That's the hard part. And which one you leave. Okay? We also have R, because I should use the right color there, couldn't I? We also have red marbles, don't we?
We do.
Because if I go back and I actually read the beginning of the problem, it says, you decided to give your best friend a bag of marbles for his birthday. I'm sure you'd appreciate it. We'll flop back and flip marbles like we used to when growing up. Since you know that your friend likes green marbles better than red ones, the bag has twice as many green marbles as red marbles. I put that in red for a reason. I guess I shouldn't have just give you any. Put that in green for a reason. Okay? Write an equation or systems of equations. Systems means it's going to be 2 equations, like you have over here that we're getting ready to solve. So you're going to have one simple equation and one equation that will have both variables in it. So you would solve for it. All right? The label on the bag says it contains a total of 84. know that it is a 4. Okay, so you have to find the green marbles and you have to find the red marbles. So you will solve for one first, like we've been doing. Then you'll plug it back in and solve for the other. Right. Like what? What'd you say?
Nina and her nickels are the other one.
Yes, it is. The nickels one? Mhm. So don't be tricked though, because it says the bag has twice as many green marbles. So then it also says, be sure to check your answer when you're finished. So you have to, if you see what you have left, like how many come out with green marbles and red marbles, make sure you plug it back into your main equation so that the green marbles are twice as many as the red. That is what Logan switched. Okay, that was his argument. He's like, no, that's not what it says, Grayson. He had his numbers switched. Right, so don't make the same mistake. Okay, let's go back to page 3. Look at those carefully. See which two you would like to do together and the other two. So those two on here and the one on the back are going to be your homework, and that's it. Okay, right? Pick one, Jackson.
That we're doing together?
Yep.
Okay.
Oh,
What?
yeah.
He always does that in class. He always picks the simplest questions. Okay, hear me. D? Okay. And what one would you like to see? Emily? B? Okay. So B and D it is. We're gonna do, slow down. You see how it was writing earlier. And then recalibrate it again. All right, so we're going to use substitution. Okay? The top equation is nice because it already says C equals negative B minus C. Now, I know it's not X, Y, but you're still going to put B, whenever you come up with B first, and then whenever you come up with C second. Okay, so wherever C is, you're going to put minus B minus 11 plus 6 equals 6B. Okay, so now you have to use the distributive property. You have to multiply that 3 inside. So we've been doing this in pre-algebra. So we're doing the distributive property first, and then we combine like terms. So it's 3 times negative B. What should you say, Carter? 3 times negative 11.
Yeah.
See, that was a B, and I thought it was a 6.
I think it's 6 of a B.
It's a B, sorry.
Oh, no, I wrote it out.
What a weird. Oh my God.
Yeah, my handwriting is not good. If I could write in cursive, it would be better. Okay, so now we combine like terms. We're going to swing that 3B over to the other side because it's negative. It'll make it positive. And so then we have how much? How many B's?
Yep, 90. No.
Yep.
Yep, 90.
90.
9.
Okay, then what is negative 33 plus 6?
Negative.
What?
Negative
Well,
7.
we take the sign of the larger, which is negative, and we subtract 33 minus 6, which is 27. That's correct. Now what do we do our last step?
Divide.
Divide. Good. By 9. So what is B? Negative 3. Right. We're not done yet. So that's our first coordinate, where these would intersect at. So now we need to use the top equation again and plug that in to find out what C is. Okay, so C equals negative B, use those, use those parentheses. So negative b, which is -3, parentheses, minus 11. So negative times a negative is a positive, good. And then 3 minus 11 is, right, -8. Now, if it asked you to check it, then we would check it just like you guys said. We would plug it back in and see if it's right. Which I could, again there, I put -3 in for B, that makes that positive, -8. Good job. Okay, so now we're going to B, or not to B.
A.
We're not doing A, it's easy.
Scott, I know how to do it.
I did A the other day and I'm like, why did I do A? It's so easy. Actually, C is the hardest one on there, just so you know. Okay, no, I'm not doing C. I already told you it was hard, so don't second guess yourself.
Yeah.
All right, so ever Y is, see this one's in opposite order. You're going to put parentheses, X minus 4. And you have a negative out in front with that 5.
Could you?
Now, make sure you don't forget something like that 29 at the end. Okay, make sure you don't forget anything. So now we distribute. -5 times X is good. -5 times a -4 is
20 from 20.
very good, 20. Automatically go to that positive. Plus 8X equals 29. What's 8X minus 5X? Very good. Again, you can start skipping some of these if you can do them in your head. Okay, like this step. You know it's positive. Now, if you keep making simple mistakes, then I'm going to make you show me every step. You know you do the opposite. It's positive, so you subtract it. What is 29 minus 20? 9. What's X? 3. Very good. 9 divided by 3 is 3. So I have my first, I have my first coordinate, which is 3. So now I have to substitute that back in to get Y. Okay, because it's written backwards, but I still put it there. So Y equals X minus 4. That you can do in your head, right? What's 3 minus 4? -1, all right. And you're done. You just have to show me this part. Okay, that you know that it needs to be substituted back in there. Okay? All right. So this isn't due until next Monday. So do your Khan Academy.
Okay.
You caught up on the rest of your work for your other classes. Get this finished. Okay, you'll be here tomorrow. If you have any questions, you can ask me. But I'm not gonna tell you. I wanna see your work, and then I'll say, oh, you made a mistake here, okay? And you need to see her.
I'll be honest, I don't know how to do this backwards. I made
Work
a
it backwards is what I told Grayson and Logan. Work it backwards first.
So it starts with R2.
Not R2, would you write it like that? Would you write it?
2R.
Yeah.
I wrote them backwards.
Yep. See?
So-
Start there. Start there. Okay, Lucas, you got a great start.
I'm gonna write that down.
You eavesdropping.
No, I was watching it. I just thought that
Yes, so
out.
A, like.
I actually don't know what to do.
Good job, you got a good start, Lucas.
Actually, it was nothing.
Yes. And we said 2 times 3x. There's stapler back there. Yeah.
No, that equals 9x.
Then you do 6x minus 5x, and you just get x. And you're done. And you need to substitute that back in. Yeah.
And I don't have a resource period anymore, so.
Let us do. Well, you guys, you have Spanish, don't you?
Yeah.
You have to go to Spanish.
I don't know, at least in Spanish.
Wait, let's just do
Monday.
I'm gonna try to do the meeting.
No.
Well, you'll, oh, I gotta stop. This will be saved, so you can look at it. So go back and watch this again, okay? All right, Jackson?
Yeah.
Go back and watch it again.